All right, pre-cal 30, number 1 on section 5.4. I'm going to do number 1, 2, maybe a little bit of 4, and maybe 9 if we have time. So number 1, can you guys see that? If you want to turn that first light off, you can, so you can see the board a bit better. Thank you. Okay, so it says in number 1, use the graph that's provided, this one right here, of y equals sine x to determine the solutions to the equation sine of x equals 0. So remember, when you have anything equals 0 and you're asked to solve, you're finding values of the variable that make that that left side of the equation equal 0. So that is, on a graph, those are your intercepts, your x-intercepts. So if you're given the graph, you are looking for the x values that are the x-intercepts here, okay? So you don't have to do any fancy calculations, you just look at the graph. We want to spot where the interval here, where the domain is restricted, and that is from 0 and including 0, so to the right of this line, and 2 pi, just to the left of this line. So I'm looking and I'm seeing x equals 0 is 1. You don't like that color, do you? X equals 0 is 1. X equals pi is another one. That's an intercept right there. And x equals 2 pi. Pretty easy, right? Those are the x-intercepts. Therefore, those are the solutions to that equation, sine x equals 0. Okay, what's the general solution for this, sine x equals 0? And there's a general solution because this is a periodic function. It repeats forever and ever in both directions. So I guess you could say something like, for b, there's different ways you could write it, but you could say x equals 0 plus, now how many, what's the distance between the next one? It is 1 pi. So pi n. You could say x equals 0 plus pi n, where n is an element of integers. That is positive 1, positive 2, positive 3 times, or negative 1, negative 2, negative 3 times, and so on. Okay? C, determine the solutions for sine of 3x. Okay, so here's where it gets a bit tricky. What you have to understand is that sine of 3x, the period length now is, 2 pi over b now. So that's 2 pi over 3. So one period length will now be 2 pi over 3. This is 1 pi over 3. That's halfway through. So we're looking at something like this, right? That's 1, and there's going to be another 1, and there's going to be a third 1. Okay? So 3 also, if b equals 3, that also means there's 3 cycles in what would be a regular 1 period for the regular sine graph. So there's 3 cycles in 2 pi, so this is 2 pi. So what we have to do now is figure out what x values these intercepts are. All of these, okay? So that's going to be x equals 0 for sure. Because the period length is 2 pi, I know that I have an x-intercept at 2 pi over 3. Sorry, 2 pi over 3, I meant to say. So at 2 pi over 3, also at 1 pi over 3. Right? So it's the beginning, that's halfway through, and all the way through the cycle. So that each intercept is just adding 1 pi over 3 to each intercept that we have. So this is 3 pi over 3, which simplifies to pi, 3 pi over 3. And then 4 pi over 3. And then looks like 5 pi over 3. And then 6 pi over 3, which is 2 pi. So all of these intercepts are what you're looking for 1C. Okay, any questions about that? Go ahead and check the answers to make sure I'm doing this correctly. But does this agree with those of you that have done this one already? Does that look right? Yeah? Okay, any questions about number 1? Kind of get it? Okay, let's do number 2, see if you get it. I'm going to do 2A anyways. So this one also gives you a graph to look at. So this is the partial sinusoidal graphs are shown. They're intersected by the line y equals 6. So this is y equals 6, okay? Each point of intersection corresponds to a value of x, or y equals 6. For each graph shown, determine the approximate value of x, where y equals 6. That's a pretty wordy, but it's basically saying what x value matches with y equals 6 on each of these graphs, and those intersection points are where y equals 6 on that blue graph, right? So you're actually just looking for x equals, what's the x value of this intersection point? And it's approximate, so you just get to guess. So this looks to me like maybe 1.2, I don't know, something like that. Approximately 1.2. And also x is approximately equal to maybe 4.7. Well, this is 5, so is that halfway through? I gotta look. Yeah, maybe 4.5, I don't know. 4.5, okay. 4.5, sure. So you just look at the graph and just find out what the x value of the intersection points are. Okay? Same for the rest for number 2. But let's move on to number 4. Okay, so number 4 is where you're going to have to use your graphing technology. So you guys have graphing calculators in front of you. So we're going to use graphing calculator. I'll have mine on the screen here. Just a note before we start. I'm going to do 4A for you, or with you. There's 4B up there. The reason why I have 4B up there as well is because I want you to notice the difference between the restricted domain here. This is 0 to 2 pi. This one is 0 degrees to 360 degrees. So this is radians, the first one. This is degrees. So when you do this on your graphing calculator, the answer is obviously going to be in radians for this one, okay? In radians. This one, the answer should be in degrees. So when you graph it for A, okay, when you graph A, you're going to want to go to, let's see, mode, and make sure your calculator's in radians, okay? Because when you find these intercepts or the x values of the intersection points, you want the answers to be in radians. For B, you want it in degrees.
Will be holding at 12 at Mr. Stevens' classroom.
So you want this in degrees for B.
Will be holding
okay?
At 12 at Mr. Stevens' classroom.
Which, I think that means 1203. They said 1203 before, at the end of the class. But anyway, so for B, you want to change your function of your calculator to degrees, then you get the right answer when you graph, okay? So I'm going to go back now. All right. Okie dokie. So, now you have 2 options for this one. Remember the 2 graphing options? You can make everything equal to 0. So I could subtract 16 here, right? And make these would cancel out, and then this would be equal to 0. It would just be this equal to 0, and I could find the intercepts. If it's equal to 0, find the intercepts. If it's not equal to 0, then you have 2 separate functions, and you graph them separately. Y equals this, and y equals this, and then you find the intersection points. So those are the 2 graphing methods. I've taught you that before a couple of times. So it doesn't matter which one you use, you'll get the exact same x values. So I'm going to do this method where I graph them both individually. So I'm going to go to my y equals. The other classes use these calculators. Their plots might be on. Please take your plots off. It might interfere with, you might see dots on your screen for no reason, and it might actually not allow you to graph something if you do. So clear everything else off. Hit the clear button. So let's put this in. Now I'm in radians, so I'm going to do this one. So negative, remember this is your negative button down at the bottom, not the side. That's a minus. It's different. So negative 2.8 sine. And I'm going to have to use some brackets here for sure. So pi over 6. Okay, I have brackets. I'm going to do pi divided by 6. That's how you do that. And then that's going to be times another set of brackets, x minus 12 bracket, I think. 1, 2 left brackets, 3 left brackets, 1, 2, 3 right brackets. Good. Plus 16. Okay, I think I got that right. And then the other side is 16 itself, okay? All right, pi over 6, 6 minus 12. Okay, now your zoom may be way off from a previous question, so I just suggest hit zoom 6, and then we'll go from there. We're going to have to make some adjustments. Zoom 6, nothing? Nothing shows up? Okay. All right, so you could zoom out if you want. That's a good first step. Zoom out, then see, oh, here we go. We got some lines coming. That's great. 0 to 2 pi is actually 0 to about 6.28, right? So I know I need to...
you could set your window as...
I'm going to change my window here, you bet. So this is 16, right? This is where this line is, 16. So my window, let's see, my x, I'm going to go from -1 to maybe 7. Okay, 6.28 is what this decimal value of 2 pi is. So I'm going to go just beyond that. And then I'm going to go somewhere around 16. So I'm going to go like maybe 10 for a y minimum, and then 22 maybe. And so let's see what that does. Okay. That looks pretty good. That looks pretty good. So I'm going to find these two intersection points because this is 0 to 7. So 6.28 is going to be right around here, right around there. And I can see everything. So I've got I'm going to have two answers, looks like. Unless this is less than 0, which I don't know. I think that might be just exactly 0. So let's find the intersection point. Second function, trace, number 5, intersect, okay? It'll ask you whether this listed above and where the cursor is blinking, if that's the first curve, and you say yes. Because we only have 2, it shouldn't be a problem. This is the second curve, yes. And then you can move your cursor over if you want, but for the first one, we'll just let it pick whichever one it wants. So x equals 6 is the intersection value for this one. So here we go. X equals 6 is our first solution. And that is inside of 2 pi, because 2 pi, remember, was 6.28. So x equals 6. That's great. Doesn't have to be pi anything. It could just be a nice even value. Okay. Any questions so far on that? You have issues? With math or in general?
In general and
Yeah, both, eh?
yeah.
I can probably help you with the math ones. Let's just say that, yeah. And I'll pray for you for the other ones.
I don't have money, so you just
You don't have money?
yeah.
Okay, did you just put your hand up just to tell me you don't have money? Is that, because that's a little different, that's kind of like out of, yeah, it's off topic, just a little bit. Okay, so you have a question with the calculator?
Yeah.
Okay, I'm gonna do this one more time up here. And if you still need help, I'll help you. Okay, so if you have both of these inputted into your calculator, the two, okay, then you want to go second function, trace. Do you want to find out the intersection point there? And you have to adjust your window so that you can see the intersection point you're looking for. So I have both of them on screen. This is good. So now I'm going to go, it's going to ask me first curve, here it is listed, yes. Second curve is the 16, yes. Now I want to move this cursor, and you can just use your button here. I want to move it closer to the other one so that that calculator will know that I want this one to be found next. So I'm going to put my cursor near there. Please don't use this value. Hit enter so it'll calculate an exact value. And there you go. Now, this number, when you have like an e to the -13, okay, remember that's scientific notation. So this is 3 times 10 to the -13. That's actually 0.12 zeros and then 3048. So that is pretty much 0. Okay? The calculator has to pick one of a million points. And sometimes it hits 0, and sometimes it hits something just a little bit besides 0. So when you have e to the -10 or 12 or 13 or 14, or that shows up sometimes, that's just 0. Okay? So his x is 0. So 6 and 0. Capiche? And these are in radians. These are radians. You don't have to have your units there, but just understand those are in radians. Okay, so I will leave the next one for you. Please switch. You'll have to switch your mode to degrees, and you'll also have to change your scale, okay? Because now instead of 0 to 6.28, you've got 0 to 360. So you have to change your window on your calculator. All right? I will leave the rest with you. There you go. Good luck.
That was easy.
Not.
That was easy.
What? Apparently they don't have those in the States.
That was easy.
Apparently they don't have the that was easy buttons in the States.
That was easy.
There's no easy button in the States?
No.
That's too bad.
It's funny
That was
I had
easy.
to send someone one because
That
they
was
didn't have
easy.